Stacks. Stack is nothing but it is a linear data structure that follows last in first out principle or first in last out principle, which means the element which came last would come out first, or the element which came first would come out last. LIFO means last in first out, last in first out. FILO means first in last out. In the stack data structure, the element which came last would come out first, the element which came first would come out last, and it has only one end which is called the top end. We will be using only one pointer which is the top pointer, this would be pointing the topmost element in the stack. And the stack is an important data structure which stores its elements in an ordered manner. Where you want to store the elements in an ordered manner, you are supposed to prefer only the stack data structure. And also with the help of the stack data structure, the elements can be inserted or removed only from one end, not from both ends. So, both the insertions as well as deletions will be performed through only one end. It contains only one pointer which is the top pointer pointing to the topmost element of the stack. So, whenever an element is added in the stack, it is added only on the top of the stack, and also the element can be deleted only from the top of the stack again. In other words, we can call it as the stack can be defined as a holder or as a container in which insertion and deletion can be done from the one end which is known as the top of the stack. Let us see the representation of stack data structure. And this is how the stack would look like. It would look like a container. For example, I want to insert an element, a new element which is 5. So, the element can be inserted and deleted through only one end. If you want to insert through this end only, it can be inserted, and also if you want to delete also only through this end, the element can be deleted. For example, I want to insert a new data element which is 5. Only through this end the element can be inserted. So, I can put 5 inside the stack now. Then again I want to insert new element which is 10 into the stack. Then again the 10 can be inserted, can be placed only on top of 5. Whatever the element we are inserting newly, that would be placed on the topmost position of the stack. So, after inserting 5, the new element can be placed only on top of 10. Then again the next element can be pushed on top of 15 only, top of 10 only. For example, I want to insert a new value 15. In this 15 can be placed only on top of 10. And also, as I discussed before, there is one pointer we will be using which is called the top pointer. Always this top pointer will be pointing the topmost element of the stack. Now, I want to insert a new element which is 20. This 20 can be inserted only through this end, and this 20 can be placed only on top of 15. The current top element was 15. After inserting the new element 20, this top pointer should be incremented one position, and now after inserting the new element 20, the top pointer will be pointing this 20, which means this top pointer would be always pointing the topmost element of the stack. Now, if you want to suppose remove the element 20 alone can be removed. For example, if you want to remove this 10, this 10 cannot be removed directly from the stack. Why? Because the stack's data structure nature is both insertion and deletion can be performed through only one end. So, when it comes to deletion, you can't delete this 10 directly, only you can delete this 20 since this 20 is acting as the topmost element. So, first you have to delete 20, then 15, and then only this 10 can be deleted. After deleting the 10, again you have to push back 15 and 20 again into the stack data structure. So, if you want to perform the deletion can be performed only on the topmost element of the stack. For example, I want to delete 20. Now, the top pointer is pointing the topmost element which is 20. Now, I want to perform deletion. This 20 can be deleted now, which means the 20 has been deleted from the stack. Now, the top pointer should be pointing this 15 only, because after deleting this 20 out, only through this end the deletion can be done. After deleting 20, only inside the stack there would be 5, 10 and 15, 3 elements only are there in the stack, and now the top pointer should be pointing 50. Then again I want to perform deletion, pop the topmost element. Pop means deletion, push means insertion. So, after deleting this 15 again, the 15 would come out of the stack. Now, inside the stack only there are two elements 5 and 15, 5 and 10. After deleting the topmost element, the top position must be decremented to its previous position. So, this is how we are supposed to perform insertion as well as deletion using the stack data structure. And let me explain you the stack using simple analogy. For example, you just think of a stack as a stack of plates in a kitchen, and there is a kitchen and you have stack of plates like this, plate number 1, plate number 2 and plate number 3, right. Now, if you want to remove a plate or if you want to add a new plate, imagine you have a stack of plates like this in a kitchen, and if you want to add a plate, when you want to add a new plate to the stack, only you place it on the top. Imagine that this is plate number 1, plate number 2, plate number 3, and after adding a new plate, this is going to be plate number 4. If you already have a stack of 3 plates or 4 plates, you can add a new plate. Again, if you want to add a new plate, that is plate 5, plate 5 can be added on top of plate 4 only. And if you want to perform deletion, the deletion can be performed, as I discussed before, only from the top of the stack, right. So, if you need a plate, if you want to place a plate after washing a plate, if you want to place it back in the holder, you can place it one top of the another. Now, if you need a plate, you want to take one from only from the top of the stack only. So, if you want to take a plate from the holder, only the plate 5 can be removed. You can't directly push this plate 1, pop the plate 1 from the container. It's not possible using the stack data structure. Only the topmost plate can be removed. When I need a plate, I can fetch only the plate number 5 from the stack. Now, plate 5 would be removed from the stack, and again you need one more plate. Again the plate 4 would be removed, then plate 3 would be removed. So, one by one, only the deletion can be done, if the fetching can be done only from the topmost position of the stack. So, this is how the stack data structure works. When it comes to the basic operations on stack data structure, there are 3 basic operations. One is push, which means this push operation is used to insert a new element into the stack, and pop is used to remove an element from the stack, and this top operation or peek operation is used to return or display the topmost element of the stack. And also, when it comes to stack data structure, this can be implemented using 2 data structures, either using the array data structure or linked list data structure. Both the data structures can be used to implement this stack data structure, either using an array or using a linked list. For example, and also before we discuss this, like how the stack can be implemented using the array data structure and linked list data structure, let me tell you what all the type of stack data structure are there. One is fixed size stack, and another one is dynamic size stack. Fixed size stack is nothing but, as the name suggests, a fixed size stack has a fixed size and it cannot grow or shrink dynamically. If the stack is full and an attempt is made to add an element to it and an overflow error occurs, and if the stack is empty, underflow error occurs. Why? Because when the stack is full, when the stack is already full, since it is fixed size stack, when the stack is already full, you cannot add a new more element into it. Why? Because overflow error would occur. There are no space to insert a new element. And also parallelly, when the stack is empty, which means there are no the stack is completely empty. So, when the stack is completely empty, we cannot perform the removal operation, we cannot perform the deletion operation onto the stack. So, an underflow error occurs. So, if the stack is full, overflow error occurs, and when the stack is empty, you cannot perform the deletion operation. So, underflow error occurs. Why? Because it is fixed size stack. So, when it is fixed size, if it is full, you cannot perform the insertion, and when it is empty, you cannot perform the deletion. And the second type is dynamic size stack. A dynamic size stack can grow or shrink dynamically. Here this fixed size cannot grow or shrink. When it comes to dynamic size, it can grow or shrink dynamically when the stack is full. Here in the fixed size, overflow error occurs, but here in the dynamic size, it automatically increases its size to accommodate the new element. And also when the stack is empty, it decreases its size. So, this type of stack is implemented only using a linked list data structure, as it allows for easy resizing of the stack. So, when it comes to the fixed size stack, this can be implemented using the array data structure, and when it comes to dynamic size stack, this can be implemented using linked list data structure. So, the stack can be implemented using either array data structure or linked list data structure. Let us discuss one by one in the upcoming videos. Thank you.